Hi everyone, welcome back. Welcome back to my math channel online today. In this video, I would like to show you how to sketch the polynomial function using both factoring and sketching it. Follow up with the previous video if you have watched. We'll see from the previous video, we were given the factor forms and we sketch it. Now in this lesson, we were not given the factor forms. We have to do it by ourselves before we sketch it. Also, let me remind you about visiting my mathteaching.ca website. And I am I'm teaching the course right now. I'm making it and created the courses online based on the BC Canada curriculum, very much like North America curriculum. So I hope that my teaching benefit on the student across the Asia, everywhere you would like to enroll in the international school. I knew that like the cost of international school student is not cheap, and you have to travel to the building and you learn. Whereas now, I used to teach in the international school student as well in Vancouver. And so it's the same curriculum I am teaching here on YouTube, and the same who I am. I'm the one who teaching in the international school and delivering the course. So if you follow me here or you register to my math courses online, if you want to learn seriously, you can have a practice exercise and performance. Well, you can earn the certificates from my teachableschool.com as well. So if you would like to know about the international curriculum in North America, and you would like to learn about the subject of math. So I hope you will enjoy my video. And in this video, I would like to show you the last lesson in the polynomial function unit, because I will move on, and our next unit will be about the logarithmic function. And stay tuned for that, because that will be a lot of interesting stuff coming. Logarithmic function is a little bit complex, more than any other function, in the way of we have to take the rules and apply on the logarithmic laws. So anyway, I'm going to start right now. And if you would like to know more about my teaching website, you can visit my mathteaching.ca and see on the interesting stuff I post over there. So let's do the first question here. The first question say we have a function f of x equal minus x to the power 3 plus 2x squared plus 7x plus 4. So this is not in the factor form, so we're not going to know what multiplicity we are having it. So we're going to have to break it down. We have to factor it out. And again, we're going to look at the last constant term and decide what factor we can break this function down. So our factor could be plus and subtract 1, and could be plus and subtract 2, or could be plus and subtract 4. So all of this factor. So we can try any of this number. Now, if I try x equal 1, and obviously you know that if I put 1 in here, then we have a big number, because 7 add 4 is 11. 11 add 2 is 13. It's not going to be our weighted number. So we know that number 1, positive 1, is not working. So let's try negative 1 and see what happens, right? So we're going to try another one, which is negative 1. So we're going to say P of negative 1. What P of negative 1 equal? Follow the expression on the top. We have minus 1 to the power 3, right? And we also have a negative outside because that's a negative 4, right? And plus 2 times minus 1 square, and plus 7 times minus 1, and plus 4. Let's see if we have a 0 or not. So this will give us negative to the power 3 is negative. Negative with negative is positive. This will be also positive. But this will be negative 7. And we have a positive 4 here. So we have 1 add 2 is 3. 3 add 4 is 7. 7 minus 7 is 0. So we check the first factor is minus 1 is working. So now we know, we will say this polynomial can have a factor of p minus 1. That will give us a 0. So let's try that one. And I'm going to put in the synthetic division. We can use a long division as well, but why bother? Because why don't we try the shorter one, right? Easier. So I'm going to put here minus 1 plus 2. Let's check the descending order first. Power 3, power 2, power 1. There's nothing wrong with that, so that's okay. Plus 2 and plus 7 and plus 4. So these are on the number. Actually, I don't have to put it aside. Okay, so now what do? We know that minus 1 works, so let's put x equal minus 1. 1 minus 1, bring it down. Minus 1 times minus 1 is positive 1. 2 add 1, remember synthetic, we add, we don't subtract, right? So 2 add 1 is 3. 3 times minus 1 is minus 3. 7 times minus 3 is positive 4. 4 times negative 1 is negative 4. 4 add negative 4, subtract negative 4, 0. So now we know we divide out by 1x. So this will represent x squared plus 3x plus 4. Now we can continue to use the synthetic, but we also can use the quadratic factor. So I know that I can split this by 4 times 1. I can split this in 4 times 1. Okay. So we have minus 1, we have 2 add 1 is 3. 3 times minus 1 is minus 3. 7 minus 3 is 4. 4 minus 4 is 0. Yes, so we have this number is supposed to be negative. Negative x squared plus 3x plus 4. So now, usually when I factor in the quadratic, I don't like the first term is negative, right? So I'm going to change it by multiply all of this number by, I'm going to do it by factor out the negative side. So I will have negative factor outside, I will have positive x squared inside. This would become negative 3x, and this will also become a negative 4 because the negative times negative will give us plus back again. So now I'm going to continue to factor this quadratic equation. So I have negative inside, I have x squared minus 3x and minus 4. I'm going to spread this become 4 times 1. And I assign this in negative 4 to match with the midterm and positive. So I will factor this become 2 bracket. One number will go in here, x minus 4, and another number will go in here, x plus 1. So when I multiply 4 times 1, I get back to minus 1. I'm I add them, I get back to the midterm, so that should be okay, but make sure I know there's a negative in front here. I factor it out. So our polynomial can be expressed as on the factor multiplied together, right? So let me express them in the way we know it look like. So P, or just say f of x, will be equal, the first factor is x plus 1, right? It's come from here, x plus 1. The second factor is here, x minus 4. And the third factor here is x plus 1. Now, at this point, we have the same bracket, x plus 1 and x plus 1, both of them. So we can join them, right? And we can make this become a multiplicity of 2, because this is power 1, add power 1 is power 2. So by combining like this, we know where's our root look like and how the shape of our root, the shape of the function at the root look like. So we have multiplicity 2 and multiplicity 1 here. And we know our x-intercept will be x equal, you see x equal minus 1, and here is x equal 4. So our x-intercept will be x equal minus 1 somewhere here. Let's say this is minus 2, so minus 1 is our x-intercept, and another one is x4. So 1, 2, 3, 4. So our x-intercept is 4. And our function, if we put a negative very large on the left side here, x equal negative infinity, then negative infinity to power x to power 3 is negative, right? So if here and you power 3 it's still negative infinity. But then you have to time with the negative in front, right? So because of they both negative, they tie together, they become a positive infinity. So we know that we can start a pen up here, not down here, in the quadrant 2 and not quadrant 1 because of this notification, right? So we have, if we substitute x by negative infinity to the power of 3, still negative infinity. And negative infinity times with negative in front will become a positive infinity. So our y function will start up here, not down here. So that's the scenario. So now I am going to, what else do we know? So we start the pen somewhere out here at the quadrant 2. We also know that our y-intercept, if you substitute this x equals 0, right? So we have everything here is 0. And this 2 times 0 is 0. 7 times 0 is 0. So the constant term turned out to be the y-intercept. So we know y-intercept equal 4. So here we're going to mark it 1, 2, 3, 4. So this is our y-intercept. So we know the function will go through this. We also know at the x minus 1 right here, our function have a multiplicity of 2. So the shape like a parabola. So it's going to be something like this. Go through like that, just touch it and not across it because that's multiplicity 2. So now the function will go across this y-intercept at 4, right? And our next root is right here. And this is the x to power 3, the highest power is power 3. So we have a root 2 here, then it should have a root 1 here. And our direction, because it's the power 3, So one up, the other one will have to be down. So it's something like this. And that is the function. We can sketch it. Balance a little bit. Something like that. So that is our function for this sketching based on the factor which it did. So we're done with the first function. So now let me show you the second function. The second function is a little bit more complex, right? It's more number, and so we have to be careful in terms of factoring it out. So again, we're going to factor the number 9. What is the factor of constant term here? Plus and subtract 1, plus subtract 3, plus subtract 9. So we try all of this number until we get the term here 0. So if we try 1, let's say if we try positive 1, does it work? 1 here at what? 3 here at 4. 4 is and if we put 1 in here, it's positive 1, so that would be negative 6. Negative 6 with 10 is negative 16. Negative 16 with 9 is negative 25. Negative 25, and we have positive 21 in here. So if we have 1, we have, if we have positive 1, we will have minus 6, minus 10 is minus 16, minus 16 at minus 9 is minus 25. If we put 1 in here, the positive will be 1, at 3 is 4. 4 at 21 is 25. So it seemed to work if we get the 1 there. That's right. Yeah, so if x equal 1, it worked out. Okay, let me see. We can try by dividing down by 1 first, or we can try a bigger number, then we don't have to divide too much after that. So what about if we try 3? The 3 will work because the 3 will divide it down, even though divide it down better for us, right? So let's try the 3 as well and see what happens. So we have, okay, so I'm going to try it down here. So we say f of 3. Then we have 3 to power 5 if it's positive, plus 3 times 3 to power 4 minus 6 times 3 to power 3 minus 10 times 3 to power 2 plus 21 times 3 minus 9. Okay, let's plug in the calculator and see how it's going to make it fast. So I have 3 to power 5 at 3 bracket 3 to power 4 minus 6 bracket 3 to power 3 bracket minus 10 bracket 3 to square bracket at 21 bracket 3 minus 9. So after I key in on the calculator, I don't get the 0, right? So therefore the 3 doesn't work. So let's try a positive 3 and see what happens, or negative 3 and see what happens. Okay. So positive 3 doesn't work out. We're going to try the negative 3. So negative 3, we will have negative 3 to the power 5, adding with 3 times negative 3 to power 4, minus 6 times negative 3 to power 3, minus 10 to negative 3 to square, and add 21 times -3 and -9. Okay, so let's check it. So you can key in -3 to power 5. You get this number -243 and plus 3 to the -3 to power 4. Okay, so let's see what happened. Now 3 times with -3 to power 4, 3 to power 4 is 81. 81 times 3, we got 240, positive 243, same number. Now -6 times with 3 to the power 3 is 27, and it should be negative. So negative times 6, so 27 times 6 is 162, and this should be positive 162 because this number is negative. So this will give us 9, positive 9. 9 times -10 is -90. This will be us 21 times 3. We are 63, so we have -63 and -9. So let's add on. Now this will cancel with this already, so we know this is 0. So now we get the rest will be 162 -90 -63. 162 -90 -63 -9. You get 0. So yes, we can both divide it by 1 or divide by -3. Now between that, it doesn't matter. You can divide that using synthetic by 1 or by -3. But I would like to divide by -3 first, because if the number is big, right, you divide down more and more, then the remainder will be smaller, right? So it's just like common sense, right? So I'm going to use -3 at dividing down. I'm going to borrow the ball from here to do that. So we're going to copy the coefficient only, right? So we have 1 for x to power 5, 3 for x to power 4, -6 for x to power 3, -10 for x squared, plus 21 for x, and -9. Now all of this will divide by -3. Let's see, so I'm going to divide by -3. So 1 will bring it down, 1. So we have 1 times -3 is -3, 3 -3 is 0. 0 times -3 is 0. -6, bring it down, -6. -6 times -3 is positive 18. And -10 plus 18 will be 8. 8 times 3 is -24. 21 subtract -24 is -3. -3 times -3 is positive 9. So 9 -9 add 9 is 0. So now at this point, we know that this will become x to power 4 because we divide down by 1x level. But let's say instead of turn it into the number of x4 and 0x3 and -6x squared, right? I just pretend that we're going to try down another synthetic division to see if we can divide out again using synthetic division. So let's check what number put in here will work. Let's say if x equals 1, we substitute here, this is 1 of x to the power 4, right? So 1 and -6 will be -5. minus 5, a minus 3 is positive 5. Positive 5 minus 5, 0. So the 1 will work. So if x equal 1 will be another factor of the syntactic division. So we can continue divide, right? We say x equal 1 work out. So we will try it. Now 1, going to bring it down. 1 times 1 is 1. 0 at 1 is 1. 1 times 1 is 1. Minus 6 times at 1 is minus 5. Minus 5 times 1 is 5. A at 5. Sorry, minus 5 times 1 is minus 5. A minus 5 is 3. 3 times 1 is positive 3. So negative 3 and positive 3 is 0. So at this one, we reduce to lowest level. So at this level, we have x down to power 4. At this level, we have x down to power 3. So this number will represent for the x square, right? Okay, let me see. This number will represent, this number here will represent for x4. And this number actually represent x to power 3. X to power 3. So it means we can try another syntactic to see if it works. It seems another one will work in here because if x equals 1, then 1 at 1 is 2. 2 at 3 is 5, minus 5. So yes, we can have another x factor equal 1, and then we divide using syntactic divide again. So 1. 1, bring it down. 1 times 1 is 1. Add them will be 2. 2 times 1 is 2. Minus 5, add 2 is minus 3. Minus 3 times 1 is 3. So minus 3, sorry. 3 at minus 3 is 0. So now this number, so remember all of this number represent the x to power 4. And then when we divide again, we get this number, and this number represent x to power 3. So now we divide again, so this number will represent x to power square. So here we have x squared at 2x minus 3. So we left with this last one, haven't factored out, but let's see if we can factor it out. So I'm going to have to borrow. So our first factor, let's record. So this polynomial f of x or p of x, right? First factor equal x plus 3 from here, right? And the second factor is 1, right? So time with x minus 1. And there's another 1 down here, right? 1 times 1 is 1, yeah. So time another x minus 1 for this one. So the last one, we're going to use a quadratic and factor. So we have 3, I'm going to factor. So this we call a completely factor, right? We keep factoring down until it's completely done, unless we have to stop because we cannot factor further. But if we can factor further, just we keep factoring down until everything done. We have on in the factor form. So here will be 3 times 1 and got to be plus 2. So I'm going to assign this plus and this negative. So we can break this, become x plus 3 times with x plus 1. Sorry, x minus 1. X minus 1. So all of this multiplied together, x plus 3 times with x minus 1. All of this factor multiplied together is this expression, right? After we factor them on like that. Let's check to see if I make any mistake. First factor, x plus 3 come from here because this is minus 3, right? So x plus 3. Second, x minus 1 come here. Second, x minus 1 coming here. And this coming from this two bracket, x plus 3 and x minus 1. Yes, so it seemed to be correct. It looked like correct, not C, right? Okay. So now let's see what happened. We have an f of x with all of this in factor form. Is there anything we can combine? Look like we have two brackets here, x plus 3 and x plus 3 here, the same exactly. So I'm going to combine them and put in multiplicity 2 because they are the same exactly. So I put in the power x plus 3 to power 2. What else do we make? X minus 1, x minus 1, x minus 1. So again, we can change this become x minus 1 to power 1, 2, 3. So we reduce down to these two root here only. One is the root of 2 and one is root of 3. And root 2 and root 3, yes, we have root of 5. The highest degree here is x to the power 5. So now I'm going to plot the x-intercept. Our x-intercept is at x equal minus 3, right, based on this number, x equal minus 3, and based on this number, x equal 1. So minus 3, somewhere here, minus 1, minus 2, minus 3. That's our x-intercept for the first one. And x equal 1 is the second root. 1 and 2. So this is the second one. And at x equal minus 3, we have the multiplicity of 2. Now let's check, do we stack the pen up here or down here? And probably I am going to have to erase this. So we have room to sketch the function. So let's see. If we have a negative infinity right here, substitute for x. This is positive, so there are no negative in front. So this is still negative, so nothing changed. If we have negative infinity to power 5, just negative infinity, it means the y function will be negative infinity. It will be down here. And go through this root, it's the multiplicity of 2. What about the y-intercept? We forget to talk about that. The y-intercept can be based on this constant because if we put x is 0, this term becomes 0. This term also 0, 0, 0, 0. So minus 9 is the y-intercept. So let's say we have minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9 down here. Have to move this out the way. So let's put here our x will be equal x plus 3 to the power 3 times with x minus 1. 2. No, this is power 2 and this is power 3. Okay. So let me. So minus 1, minus 2, minus 3, minus 4, 5, 6, 7, 8, 9. So this is minus 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our y-intercept right here. And our function start from negative infinity from here, like a parabola goes from here and go across this. So let's shape this one first. And then at here, it becomes multiplicity 3. So it will go up here, and because it's multiplicity 3, so we will have the shape look like, this is my skinny shape first. It's me. So let's say at here is municipality tree. So we're going to do something like that. And then what next? What is the direction? We have x power 5, one up, one down. So this is down, the other one should be up. So then it should be something like this, up. So this is the second draft we sketch based on the factor form. I hope you enjoy my sketching video for polynomial function. So in the next video for my next lesson, I will talk about the new unit. So stay tuned for our math pre-calculus 12, and we'll show you another video about the lesson in logarithmic function. So we're done with the polynomial function. In the polynomial function, what did I show you? I show you how to find the factor theorem, remainder theorem, factor theorem, and how to factor using the rationalized zero theorem as well. And I show you what multiplicity means, and I show you how to sketch the polynomial function. I also, in my previous two videos, if you would like to know, I also show you how to solve the word problem, four words problem from the polynomial function, the application of polynomial function to solve the words problem. So I end the unit here, and then the next unit, I will show you about the logarithmic function. Thank you for watching, and bye for now. I hope you learned something.